Welcome to From Proposers Day. I'm Tyler Best, the Acting Director of the Health Science Futures Office. The agency is divided into 4 research offices to achieve our mission of accelerating better health outcomes for all. We are an ARPA, Advanced Research Projects Agency, modeled after the Defense Advanced Research Projects Agency, which is actually across the street right here. DARPA, you may have heard of and you may be familiar with. They were launched in the 50s in response to Russia launching Sputnik satellite here. Some of their big things that they are well known for is the developing of the internet. This is a napkin actual drawing of the nodes between the various centers that first established computer-to-computer communication. DARPA has done self-driving cars, stealth bombers, et cetera, et cetera. We, as an ARPA, feel that we can do the same thing for health. And front, if we are able to be successful in replacing cortical tissue, we see that as a self-driving car, and maybe an internet-like achievement for humanity. This is who we are. We're organized around program managers who develop and generate program ideas. We try to move quickly, like a startup would, a small business would. We deploy flexible funding tools. That means the funding that you would receive are called other transactions. Those are not grants. Those are not contracts, but other transactions. And so there is active program management by John and his team on what you will be doing and achieving those milestones. When John comes in, the first few months of his time here was on planning and initiation. We launched the solicitation, in which you are all here now. We're at this stage here. Hopefully, in the next few weeks, coming months, he's going to be evaluating all your fantastic proposals, selecting those, and then negotiating your awards. At which time, then it's to work, working on those and performing on those milestones and metrics. And ultimately, if it's successful, there will be completion and close out of those things. Those programs are based on a specific challenge and focus area that really is meant to drive towards deliverable and outcome-based rather than exploration. We have a lot of freedom to operate. Similar to extramural NIH or the NSF, we are a funding agency. We don't have internal labs, intramural labs that do the work ourselves. We are disease agnostic. In this case, it is front is focused on cortical replacement for whatever needs there. You know, there are some obvious examples of needs with stroke or traumatic injury or other things. As I mentioned, we don't fund grants. It's other transactions which are actively program managed. We have unique authority to interact with other government agencies where we can fund things directly with FDA and so on and so forth. Our program managers are term limited, as am I, at a 3-year time frame, renewable for a second 3 years up to 6 years. That ensures that fresh ideas, new vision, new ideas come in on a consistent basis, so we don't get stagnant. We don't get kind of caught in the mire of old ideas. We have a lot of bottom-up decision making. Jean makes, and his team, based on the reviews of the proposals, will make the decisions on which teams to fund and in what regards. They don't have to fund the entire proposal. They can pick and choose parts of a proposal to fund to meet the objectives of the program. Jean brings that recommendation to me. I ask questions about it to make sure everything is solid and have other external considerations into account. But then ultimately it's up to Jean, and those contracts, those awards are made, and you all begin negotiating and starting to work. We have a lot of stakeholders, customers across the federal government, as well as the private sector. We consider the people doing the work as performers. That's academia, companies, nonprofits, et cetera, the private sector. We want stakeholders to also be on the patient engagement side, the clinical side, that are going to end up using the products, the technologies that we develop. We don't want what we develop to sit on a shelf somewhere. We want people to actually enjoy using it and have it be functional and user-friendly. John came in as a program manager with an idea, a challenge that he wanted to solve. Jean wants to be able to solve this loss of cortex, and the way that in which he's designed the front program is one way that he sees the future of solving that problem, that challenge. We've launched the program, and you are all here because you want to be performers, teams to do that work. As you are awarded the work, you may not be successful, and that's okay. At certain points, you'll progress through the milestones, the phases of the program, and if not successful, you can move on. You don't have to continue the work. Jean and yourselves will have discussions, really deep discussions on whether or not your work is worth funding in perpetuity to continue on or not. Or you may be wildly successful, and Jean and his team realize that you need more money to do more work, and so he has the flexibility to give more funds to do to finalize, to branch out and do more work that's going to lead to greater success. We've already, not on any of Jean's programs, but on another program, we've already had to cut a team that was just not making progress. That's fine. It was a risky thing. They knew it was risky going in, and it just wasn't working. And so that team, that award was ended. As I mentioned, we're divided into multiple offices. I'm the current acting director of the Health Science Futures Office. We like to really go after more of the science fiction like stuff rather than scaling things up and out to the people, or making things more robust, more resilient, or being more proactive in preventing disease and health. And if you'd like, there's some example programs that we have already launched there. We have an eye transplant program, 3D printing organs in print, Oculab, et cetera, you can look on our website. With that, I will turn the time over to Willie for some remarks.
Thank you, and it's an honor to be here on behalf of HHS and the administration. Last night, as I realized that I'd agreed to speak in an event about brain regeneration, I realized I didn't have much to say about it. I think it's hard to speak eloquently about glial cells and interneurons and iPSCs unless you're Dr. Hebert. So I'll tell a story that I know a little bit more about that I think has some Bible lessons and maybe some inspiration, which is the story of diabetes. So, for more than 2,000 years, Indian, Chinese, and Egyptian physicians had recognized something like diabetes. So they had recognized that in some people, they would develop excess thirst, they would be peeing a lot, they'd have very sweet urine, and they'd get lots of complications, ranging from problems healing wounds to what we would now call ketosis and various complications like that. And over the centuries, people piled on more observations of symptoms, but nobody ever came up with an effective treatment. The first sign of real progress and understanding came in the late 19th century with the French scientist Claude Bernard. He made some early progress towards understanding the role of the liver in driving gluconeogenesis and diabetes in general. In the 1920s, a few scientists, some of whom would win the Nobel Prize, Frederick Banting, Charles Best, John McLeod, and James Collip, did some pioneering research. They disrupted the pancreas in dogs and found that when they did this, it caused immediate and severe diabetes. When they added pancreatic extract back in, it seemed to cure the resulting diabetes. And then from there, progress came relatively quickly. So in January of 1922, they first tried a pancreatic extract in a human with diabetes, and they saw some improvements. By 1923, Lilly had commercialized the first commercial insulin. Over the next 2 to 3 decades, using animal extracts, they improved the purification methods, they changed the formulation. There were still a lot of problems with tracking, high glucose levels, with immune reactions to animal-derived insulin. And by 1982, the first recombinant insulin, so human insulin, made with biotechnology, was created. And in the 90s and the 2000s, more convenient pen insulin variations on insulin, longer-acting insulin analogs to improve glucose control overnight and throughout the day were developed. And lots of improvements in diagnostics, from fingerstick glucose measurements to now continuous glucose measurements, and insulin pumps were also made. So over about 100 years, diabetes went from a diagnosis that was fatal in a few months to a chronic disease with a plethora of treatment options. Even more recently, there's been the introduction of engineered islet cell transplants that might hold out the possibility of a real cure without lifelong immunosuppression. So for all the front participants today, my challenge would be measure your ambition by the example of diabetes treatments, hopefully make progress a little faster than 100 years. But yeah, how can we make treating brain aging, strokes, dementias as straightforward as treating diabetes is today? Yeah, excited to hear what everybody's up to and excited to see the progress that hopefully results.
Welcome, everyone. It's nice to see familiar faces and new faces as well. I'm going to tell you about our new program, FRONT, which is the functional repair of neocortical tissue. So what if we could restore function to the millions of Americans who suffer from permanent brain damage? The current treatments for severe brain damage are limited to occupational physical therapy, speech therapy, and in some cases, psychological support. And those have provide some improvement in the condition of patients, but they're limited. And they don't improve the condition of, in fact, most patients with severe brain damage. So we're really left with patients that are currently suffering without much hope of improvement. And this comes at a tremendous cost, not just to them, but to the caretakers, which oftentimes are family members that have to, on a daily basis, look after them. And overall, with the loss of the workforce that this encumbers, there's a huge yearly cost that's over $1 trillion estimated in the US alone. So that's the current state of affairs. So what we want to do with our treatment is to allow patients to reacquire function. They can return to the workforce, relieve the caregiving burden that the families are shouldering, as well as the professional caregivers, and do this with a one-time treatment that overall will reduce care costs. I'm also excited that this will hopefully spawn a new industry of tissue-level repair technology. So bottom line, we want to take the permanent out of permanent brain damage. And the way we're thinking of doing this, and I'll get into this in more detail, is by essentially growing new cortical tissue that is pretty indistinguishable from normal cortical tissue. Permanent brain damage, or what is considered currently as permanent brain damage, can arise from several causes. Stroke, neurodegeneration are the most common and most costly, but they can also arise from trauma, other causes, tumor resections, infections, neurotoxins, and a few others. There are many causes, and this approach of replacing damaged tissue could address all of those. And just so we're all on the same page, this program, FRONT, is focused on one part of the brain, the neocortex. And that's what's illustrated in blue here. It's the biggest and most superficial part of the brain, so it's the most often damaged, which is why we're focusing on it. And also, it is arguably the one that is the most important to us in that it codes cognitive functions, things like sensory perception, motor control, higher order cognitive functions like language and executive functions. So it's very important to us as individuals. So this wouldn't be an ARPA-H program if at first it didn't sound a little crazy. And so why do we think that it is possible to replace damaged tissue with new functional tissue? Well, it's based on 3 well-established areas of neuroscience. One is all the graphs that many groups have been doing in the neocortex with dissociated precursor cells or organoids, showing very reproducibly and very robustly that the neurons derived from those precursors follow their normal program of differentiation and try to integrate as best they can with the adult brain. So they'll project long distances to appropriate targets. They'll receive inputs. And so that's very promising that these cells, despite being in an abnormal environment, follow their normal program of differentiation and integration. The problem is what's been done so far lacks cell types that we know are essential for function, lacks structure that we know is essential for internal wiring of the graft. And so what's been done so far is not yet fit for purpose, and those are the challenges that we want to address to make new tissue that does recapitulate all the elements of normal tissue to be able to process and encode information normally. The second reason why we think it's possible to functionally replace neocortical tissue is the way that the neocortex functions. It's super plastic. And this is textbook stuff. It's been shown in, across mammals for different functional areas of the neocortex that functions can move and change their substrate in the neocortex over time as need arises or if induced experimentally, for example. An example that I like to give is one in humans of advanced age that have benign tumors. So they have tumors that grow, this one's a little more diffuse, but they're resectable tumors that grow slowly over time and destroy randomly different parts of the brain. If, for example, they destroy the language area, these individuals, even after the tumor is removed, and you see a hole in the brain in the bottom panel, these individuals never lost the ability to speak. And no one ever noticed that's close to them a difference in their ability to speak, because during that time, they continuously were using language, and it just seamlessly gets re-encoded elsewhere because of this plasticity with which the neocortex operates. In the cases of stroke, if you have the same amount of damage to the same area, language is gone. So there's no time for plasticity. We're thinking we can address both the slow degradation of function that can occur with tumors or neurodegeneration and the sudden damage that occurs from a stroke or trauma, for example. In one case, by being able to maintain function, in the case of the slow loss of the function, and in another case like stroke, to completely reacquire that function or facilitate the reacquisition of that function. But in any case, plasticity is an important pillar on which, conceptual pillar on which this program is built. And the third and sort of final one is that we have a blueprint for how to create normal neocortical tissue, and that's normal development. We have a pretty deep understanding of how this happens. From the beginning on the left, a very simple sheet of neuroepithelial cells that over time gives rise to the different subtypes of neuronal cells that are found in the neocortex, and what their interactions are, both physical and with at a distance. For example, radioglial processes have to maintain a stable attachment to a primitive meninge-produced basement membrane, right? And we know that if that doesn't happen, a lot of things go wrong and you don't get normal tissue. So that's just one example here of what's needed for normal development, but we know, what these components are, and we know what's been missing so far in the attempts. That's what we want to address with front. I'm going to emphasize a little bit more here that the idea is to emulate normal development. And the example, although there are several different approaches that one can imagine, the example shown here is to sort of engineer a very early precursor tissue that mimics normal early neocortical precursor tissue. And to do that, we have like high omics information. So we know using single cell sequencing, for example, all the different cell types that are there at different times when they arise, what their lineages are. We also are gaining a lot of knowledge on what is surrounding the cells. So initially, we want this tissue to grow to a large extent on its own as it does during normal development, but we need to kick it off so that it's going in the right direction. And to do that, it needs the normal environment that it's in at that early stage. And so that means omics analyses of the extracellular proteome as well as glycome. So that information is not complete, but it's achievable, and groups are working towards getting that information. And then sort of assembling that in a way that this precursor tissue can then be sort of planted as a seed in the adult to grow into new normal tissue somewhat autonomously following a normal developmental program. So that's the idea. May not happen perfectly at first. So there might be some reiteration as we graft and see how it integrates and matures. And we'll be looking at neuronal and vascular integration. Neuronal integration is going to probably be a little more elaborate in terms of analysis than vascular integration, but they're both essential. So they're both part of the program. And then ultimately, what we want to achieve towards the end of the program is proof that this new tissue can encode information that's useful to its host, right? That's essential. So a lot of the grafts thus far in preclinical studies have shown behavioral improvements, but none of them have shown behavioral improvements dependent on the electrophysiological activity of the neurons, for example. It's all from bystander effects. Put in immature cells, they secrete good factors, they help the surrounding tissue do a little better in a small brain like a mouse brain. So, factors diffuse a little distance. And those have been the basis for a lot of previous clinical trials using cells to treat stroke, and they've all failed. And it's not too surprising because the human brain is much bigger and the diffusion of these factors doesn't occur over greater distances in this bigger brain. So the impact is going to be very small. We want to be clear that we're not looking just for behavioral improvements here in preclinical models. We want proof, a demonstration that the graft-derived tissue is encoding useful information to its host. And at the same time, we want this to be, GMP, so ready to move forward to the clinic. Here's an outline of the technical areas. There are two technical areas. Technical area 1 is to come up with this precursor tissue that can emulate normal development. And technical area 2 is grafting and outcomes. So 2A is integration and 2B is function of the graft. So as I mentioned, for technical area 1, the current grafts are limited in what they can achieve because they lack essential cell types, they lack essential cytoarchitecture, and the wiring, therefore, is going to be very abnormal within the graft. So the goal is to develop a neocortical precursor tissue that emulates its natural early counterpart and meets standards for first-in-human use. So phase 1, 2A trials. And so the outcome will be a graft tissue that has normal cell type composition and the right cytoarchitecture. Technical area 2A, graft integration. So currently, my lab previously and lots of other labs do these grafts of cells or organoids. And most of the time, they don't report the rate of failure. So a lot of times the grafts just fall out, the organoids just fall out. We don't know how often that occurs. In our hands, we tried to measure what the success rate was, and the best we could do was 50%, which obviously is not good enough. So there's a lot of technology there and procedural things that need to be worked out to increase the engraftment efficiency. So that's basically 2A. And along with that, of course, is the neuronal and vascular integration as a measure of how well the graft has integrated. And then graft function, which I spoke about just now with, we're not looking for bystander effects. We're looking for a graft that functions like normal neocortical tissue to encode information. And that's the outcome we're looking for, with a significant improvement in the reacquisition of a behavior or the maintenance of a behavior. So for technical area 1, building or somehow generating the precursor tissue, there's, again, different approaches, but they're enabled by different technologies and knowledge bases, such as a knowledge of how the neocortex develops, which I went over already, which serves as a wonderful blueprint for how it can work. And as I also mentioned in one of the approaches, there's extensive omics analysis done already, but there's room for more information there. There's not complete, but that can be achieved. But the technology exists to achieve these information bases that can give us a very high resolution of what we're trying to accomplish in terms of a precursor tissue. There are IPS differentiation protocols for most or all of the relevant cell types that are found in an early precursor, neocortical precursor tissue. They can be improved upon, and that's an active area of research across regenerative medicine. So there are technologies there that we foresee making this much more robust. In addition to the assembly example of putting the different precursor cell types together with an extracellular environment that makes sense, there's also potentially ways of starting from completely undifferentiated IPS cells and growing them, mimicking again development, but even earlier stages, into a neocortical fetal-like tissue. So that's another approach that several groups are considering that could be very viable here. There's companies that have paved the way for cell-based therapies in the clinic successfully that are efficacious. They're still in clinical trials, but the results are pretty spectacular. Blue Rock Therapeutics and Aspen Neuroscience are putting in dopaminergic precursors to treat Parkinson's. Neurona Therapeutics is putting in interneuron precursors to treat epilepsy. So the results so far are very good. Safety had been demonstrated by many groups previously for cell-based approaches to the brain, but there are also no complications in their studies so far anyway. So they've paved the way. They've shown that it's possible to get these more sophisticated than small molecule or biologics to the clinic for brain disorders. But these are, simpler than what we're trying to do. There are single cell types to treat single indications. So we want a more platform technology of rebuilding tissue to replace tissue level damage. There's also companies that I won't list here, but they're really moving the needle in terms of bringing down costs by automated cell differentiation, scaling, and manufacturing. So I won't list them here, but we think that some of these will really bring down the cost of cell-based therapies to something that's commercially viable. Could be relatively cheap. Biological matter is not expensive to make. It's the reproducibility that's the problem. So I think what some of these companies are doing could make these therapies be very affordable. So very interested in that as well. This is a breakdown. I won't go through all the details here, but maybe just the top part, the Gantt chart here for technical area 1, what the expectations are. So 1 is to have all the right precursor cell types, the right extracellular environment, whether that's by assembling them together or growing them using these more advanced developmental mimetic techniques, and then validating that the positioning ratio of the cell types are all what you would want to see. And then also preparing this, coming up with a way of making this scalable and GMP ready for initial clinical trials. All right, so for technical area 2, there are also 2A, which is the engraftment part, optimizing that. They're enabling technologies. There's a literature on grafting very young tissue into adults in the neocortex, showing again that you get great differentiation and projection of neurons to the rest of the brain through normal pathways. So that's encouraging. But again, the efficiency is pretty low of engraftment, so that still needs to be worked on. But we know to some level that it can work. We also know in terms of integration that we have the tools to measure, for example, how graft-derived neurons, if you put them in the visual cortex, for example, can respond to light stimulus or visual stimulus in a way that is indistinguishable for how normal visual cortical neurons can respond to light stimulation, visual stimulation. We have the tools to measure this as well, right? And connectivity, right? So connectivity is the basis for brain function. So we need to be able to measure how well the graph-derived neurons in a quantitative way are receiving inputs from the rest of the brain and connecting with the rest of the brain, as well as internally. So the information processing within the graft itself is what's been missing from most attempts thus far. And so that will need to be measured as well. And so tools are available for high resolution, quantitative measures of this connectivity. Anastomosis, so the graft obviously needs to become perfused very quickly after engraftment in order not to have cell death and loss of the structure that was worked on so hard to achieve. So anastomosis is important. We know it can happen. So several groups have shown that after engraftment, you get anastomosis. You can pre-vascularize what you're putting in or add vascular endothelial cells that accelerates vessel formation within the graft and anastomosis, but is it fast enough? Maybe, maybe not. This needs to be tested, but there are technologies out there that could enable lower anastomosis while keeping the graft alive in vivo as it starts to differentiate. So that's also of interest to this program. So here again, I'll just focus on the top, TA2A, which is the graft integration. Year 1, 2 is optimizing the efficiency of engraftment up until year 3, making sure that vascularization can occur quickly. The specific metrics are provided at the bottom of the slide, but they're also in the call online, so you can look at it there as well. Defining both the anatomical, physiological connectivity, and some functional features. For example, if it's visual cortex, can these neurons respond to light? If it's motor cortex, if you activate them, can they elicit some sort of movement? As a preliminary to showing that they are at least functional at that level. Finally, the third technical area is to demonstrate that they encode useful information. So that's another level of functionality that's important to achieve here. And so we know, again, conceptually that there's enough plasticity. So if there is normal tissue there, it will get used. And we have maps of wiring for, in this case, the example given is non-human primates, so the macaque. So in the middle right, all the way at the right there, all the colored boxes are different parts of the brain, and the black connections are weighted for the amount of connections between those different parts of the brain that are involved in visual processing. So there's a lot we understand. There's still stuff we don't understand about how we perceive things in the world, but we do have a pretty good idea how things need to be wired and connected together in order to function. We also know that in preclinical systems, for cortical damage, there can be a lack of compensation. So this is definitely true for primary visual cortex, but to some extent true for other parts of the cortex as well, which gives us a window for demonstrating that our graphs are encoding useful function. And finally, there's a good track record of survival of human cells grafted in, for example, again, non-human primates for over a year, which is what will be needed for these grafts to differentiate and mature enough that we can start looking at their function. And we have technologies that are used, again, even in non-human primates, of transiently silencing neurons. So in this case, we would specifically silence the neurons in the graft transiently to show that they were required for a reacquired behavior, for example. And in the program, so when we're talking about function or reacquired behavior, there's a couple of ways that we've already mentioned we're thinking about. One is reacquisition and one is maintenance of behavior. So what we're requiring minimally is addressing focal damage, for example, stroke, in a primary cortex where the metrics of loss of function and recovery of function can be very precisely measured. So in this case, though, when you have a stroke, it's a reacquisition of function that you're measuring. We're also very interested in degenerative conditions that occur, like in Alzheimer's, for example, or just regular aging. And that damage is much more diffuse, and the associative cortex is affected. So in that case, the metrics are well less defined, but we encourage you to think about how you might come up with very strict metrics to measure reacquisition or maintenance of function in some of these degenerative models in the case of diffuse damage. And in this case, we're adding new tissue to maintain function over time. Again, here, just the expectations in terms of timelines. We expect this to start training animals on a task for which they will then be, a part of the cortex will be lesioned, and they will no longer be able to perform. Start that, here it says phase 2, nothing stops anyone from starting earlier in any of these milestones and timelines. But that should give enough time to train the animals and then start doing the lesioning, the grafting, and it'll take them a while to mature, after which you can start demonstrating the function of these grafts, as well as start preparing for clinical trial, assuming that you can show functionality and you have a GMP-ready precursor. This is basically a summary of the 3 previous Gantt charts to give you a visual overview of the timelines, but I won't go over it again. To add to the technical goals, so the first 2 bullets are somewhat redundant, but it's basically coming up with the precursor tissue and showing that it functions, right, in the way that we want. But we also, want there to be a plan to reduce the costs of producing this to something that is going to be viable after ARPA-H funding runs out and you have to survive in the wild with your enterprises. You need this to be cost effective. So we want to see implementation of a plan there. As with any new technology, there's going to be pushback. People are going to say, "Oh no, you can't do that," or it could cause these problems. And so very important to us is a plan to address the ethical, legal, and social implications of this program. So ELSI, and I'll go over examples of that in a bit. Also, as I mentioned, commercialization strategy, how are you going to survive and make this a viable product? Regulatory framework. So again, with any new technology, it takes a lot of discussion with the FDA to bring them up to speed on what the technology is, how it would work, and how it will benefit patients. And so those dialogues will be happening with performers and our team and FDA. And we can start those very early on once we have an idea of what the product is going to be, to make sure that we're all aligned by the time we come to first-in-human trials. And all that together, will serve the patient population ultimately. Yeah, so some general requirements for proposers. One, each proposal has to address all the milestones and metrics that are outlined in the program. That's not true for all ARPA-H programs. Some programs you can just address one TA or part of a TA. In this case, it has to be all of it. And also, it's really a partnership that you're entering in with ARPA-H. It's not like we're going to negotiate an agreement with you guys and then see you in 5 years. Not at all. You'll be seeing me on a weekly basis. Okay, we'll be talking about the science, the data, and if I can be helpful, I will. But at the very least, I will be informed on what you're doing to make sure we're really staying on track. And if we're not, if there's adjustments that can be made to get back on track, and if things aren't working, then we can part ways. Yeah, there are other documents that reflect what I talked about in the previous slide in terms of goals that will need to be provided by you guys on the basis that's outlined in the call. So getting back to the ELSI requirements, that includes very active participation on the proposer's side by having a designated ELSI person in a leadership position, part of the discussions. Also, there's going to be a lot of engagement with stakeholders and patient populations and patient advocate groups about, what their concerns are with this technology and how we can proactively address them. These are some examples. Surgery, that's too risky. Well, as with the millions of brain surgeries that go on all the time, it's a cost-benefit analysis that has to be done in each case to see whether or not it's worth it. And as the technologies get perfected, the surgical techniques and the risks come down, I think this will increase overall over time the patient populations that we'll be helping. Another concern is you're putting in new tissue in my brain. Is it going to change who I am or change my function? There, it's really important to emphasize that this is a precursor tissue that doesn't have any information in it at all and will be used by the patient to reacquire whatever they are focusing on reacquiring, right? So it's really just there to allow more of you to not a different you. So that's a consideration as well. Tumors always come up when I talk about this, when you're starting with iPS cells, hopefully less and less. I mean, there's been like over 100 clinical trials with either iPS cells or pluripotent human stem cells, which are equivalent. And, there's a very good track record and there's a very standardized procedure to avoid that. They have kits that you can look for any residual undifferentiated cells, for example, to make sure you don't get teratomas. So it's a concern. It has to be built into what everybody's doing, but it's not like an unsolved problem. And then there's the costs. There's definitely a strong argument to be made that this will save money over time with a one-time treatment where the costs come down, even initially with where the cost of the treatment may be a little higher, considering the cost of lifetime care for people with severe brain damage, there's a savings to be made there. Worth mentioning some of the things that won't be considered in the program: the use of human embryonic or fetal samples. We're not going to consider that. Efforts at enhancing cognitive function beyond what the pre-damage state was, right? So a lot of people are excited, we can make smarter people. Well, that's not this program. We're just trying to restore function. The use of human-animal chimeras, and we're talking about, how chimeras are made at the embryonic stage. Obviously, testing human cells in adult preclinical models is fine. Yeah, and we're focused on the neocortex, so might have some great technology to treat Parkinson's in the basal ganglia, but that we will not be considering that for this program. And also, you must include, consideration for these ethical, legal, social implications of what you're doing. Yeah, I think this is my last slide. So what we expect in 5 years is to have a precursor tissue that mimics normal precursor tissue in its cell type composition and structure, that can also encode useful information to its host once it's matured and integrated into the adult brain, and that it meets the standards that we will have established together with the FDA for first-in-human trials and be ready to apply for an IND. And then in the next 10 years, we'll start seeing the benefits of this in the patient population. Patients will be recovering function, returning to work, relieving burdens on families and caregivers. And we'll start to see reductions in cost. And again, what's cool is hopefully this will spur a greater industry in tissue level repair for the CNS, and there's already great interest for other parts of the body, but particularly for the CNS. So I think that's it for me. Thanks for being here.
Good morning. My name is Adria Robinson. I am an agreements officer in ARPA-H's Business Innovation Division. I am here in support of Gina Perry, who is the agreements officer for the FRONT program. So ARPA-H, we use a term for our solicitations, innovative solutions openings, right? I'm sure you all are familiar with RFPs and BAAs and all of those things. ISO is the ARPA-H solicitation, essentially. Our ISOs allow for, merit-based awards. It allows for us to focus on selection decisions that are really based on the technical merit behind your proposals. And they're really flexible, right? Our ISOs allow our PMs to really push out a solicitation that matches what they want to see in their program, and they're not limited to a structure where they might have to fit their program into that solicitation structure. So for front, as mentioned earlier, the awards will be other transactions. So we don't allow federally funded research and development centers or other government agencies to propose to our programs, but just about anyone else is eligible as long as you are not on the suspended or debarred list. We do not release the estimates for our programs, and we don't release funding, ceilings or ranges for awards. That's typically a question that we get at these events. So just putting that out there that we can't tell you, a price that you should be shooting for. Solution summaries, as you'll read in the ISO submission of those, is mandatory. Solution summaries are, if you're familiar with abstracts from other agencies, it is essentially that same concept. We'll review those and provide feedback. And if you're interested in submitting a proposal, make sure you submit the solution summary, because a proposal will not be considered if you have not submitted a solution summary. In the feedback that you get from ARPA-H on your solution summary, we will either encourage you to submit a proposal or discourage you from submitting a proposal. You may submit either way. However, if you receive a discourage, I highly recommend that you think really hard about whether or not you want to put the time and money into a proposal. Because if you receive a discourage, it is ARPA-H's way of saying, we don't anticipate your solution being successful in this program. However, again, you are able to submit if you want to. We will not review proposal submissions that are non-conforming. So with that, I say, if you take nothing else out of today, hear this. Please read every single word in the ISO. All of the instructions are important, and I would hate for someone to miss out on an award for something small, right? Like missing some little detail. So please make sure you read and follow all of the instructions. If something is not clear, submit a question. We'll make sure we get you an answer. Just again, I'll say it a third time, please read all of the instructions in the ISO before you submit. Other transactions. So other transactions are contracts in the legal sense, but they are not contracts in terms of government procurement. So other transactions fall outside of the FAR, the Federal Acquisition Regulation. They are also not grants or cooperative agreements. So other transactions fall outside of the government financial assistance regulations that are out there. I will emphasize, falling outside of those regulations does not mean this is completely the wild, wild west, right? A little bit, but not completely. We do still have laws we have to adhere to, right? We are still funding these awards with taxpayer dollars. So we do still have some rules. But the great thing about other transactions is it allows us to interact with you all in a way that is more typical with the way you interact in the commercial world. Most of the terms and conditions that you're going to see in, I believe a model was posted with the ISO, most of that document is on the table for negotiations, right? And like I said, we're not bound by the FAR, so we have the ability to negotiate a little bit more with you all than government agencies traditionally can. That being said, no two awards are going to be identical. Even multiple awards on the same program will not be identical because we're going to negotiate with each performer individually and come up with an agreement that makes sense for both parties. Eligibility, I touched on this. If you are considering partnering with a government entity or an FFRDC, please make sure you read that section of the ISO very closely. There are ways of doing it, but it's not a very straightforward setup. SAM.gov registration is required for the prime submission, the entity submitting as the prime. SAM.gov is an interesting beast if you haven't used it, right? Some of the registration requirements have changed over the last few years. So if you need to register in SAM, or if you need to renew your SAM registration, today would be a great day to start that process. If you wait until it's time to submit, there is a good chance something is going to go wrong. It's what SAM does well. So I would encourage you, if you need to work on your registration in SAM, please, for your own sake, start that very early, because we have had some people get to the day of submission, start their SAM registration, and then be unable to move forward. Section 3.2 of the ISO talks about non-US entities. We do allow non-US entities to participate in our program. So if you're interested in teaming with an entity that's outside the US, you can do that. There are some exceptions, right? There are entities in foreign countries of concern cannot participate. The other thing is the ARPA-H statute does require us to prioritize work that is conducted on US soil. So please keep that in mind as you're forming your teams. So the submission and selection process. I mentioned the solution summaries. I'll say again for front, submission of a solution summary is mandatory if you're interested in submitting a proposal. The submission deadline is Monday the 18th. Let's take a moment and talk about that. ARPA-H is preparing to undergo an IT migration, and that could impact the submissions of your solution summaries on the 18th. If we get confirmation today that that is going to have an impact, we are going to issue an amendment to the ISO, and we are going to move the due date for solution summaries up to the morning of the 15th. So please keep an eye on SAM. Again, we will let you all know that today, but I want to make you aware that that is a possibility. Appendix A, which is attached to the ISO, is your template, essentially, right? Make sure you follow it. Following Appendix A is mandatory for the solution summary template, and as long as you submit on time and follow that template, you will receive feedback. You will get a response from ARPA-H. Proposals, again, you can only submit a proposal if you submitted a solution summary. It does not matter if you received an encourage or discourage from ARPA-H. There are appendices B and C with templates, and there will be other documents that are provided when you receive your feedback that you should use when preparing your proposal. The proposals will be evaluated against the evaluation criteria that are outlined in the ISO. Proposals do not get evaluated or compared against each other, right? They are evaluated against the evaluation criteria individually and selected or not selected based on individual merit. Each step in this process, we hope to move very quickly, right? So you can expect hopefully to get feedback and notifications on your submissions pretty quickly after they're submitted. Here is an estimate of the program schedule, just so you guys have an idea of what our plan is. All of this is subject to change, but this is the plan. The evaluation criteria are on the screen. You can see there are 5 criteria. They are listed in descending order of importance. That does not mean some of them won't be utilized in the evaluation. It just means that how we rate these criteria as we're reviewing, this is the level of importance. These are all listed in the evaluation section of your ISO. Right, so when you submit your solution summaries, there's a list here of all of the things that you need to provide: a cover page, the proposed work, target product profile, timeline, org chart, describing your team. We want a rough order of magnitude of your budget. You're not bound by that number, but we do want to have an idea of what you think your solution will cost, and then any references that you want to provide. The proposals are going to require a technical and management volume, a cost proposal, which includes both an Excel spreadsheet and a narrative that supports that spreadsheet, and a document that we call our administrative and policy requirements document. Once the proposals are evaluated, you'll be notified that you were either selected for negotiation for an award or not selected for negotiation. If you are selected for a negotiation for award, at that time, you'll have communications with both the program team and the bid team on potential revisions to your documentation if necessary, and then you'll move forward into actual negotiations. I will say that the selection is a selection for negotiation of an award. It is not a guarantee that you will receive an award. So just keep that in mind. Teaming structure. So as stated earlier, teams' proposals have to be able to accomplish all of the milestones that are outlined in the ISO. Both TAs have to be covered in a proposal. The agreement, the OT, will be signed between ARPA-H and the prime organization. Subcontractor, sub-awardees will then, contract with that prime organization, not directly with ARPA-H. This slide just kind of explains that last statement I made, right? ARPA-H does not have privity of contract with any subs, so all of the communication, technical direction will go through that prime entity. So final guidance on the ISO specifically is that understand that the ISO is binding. All of the official direction comes in the ISO. There will be, questions that you all ask that we answer and post answers to. You'll see information about front in a lot of different places. But in terms of the submission requirements, how we're evaluating, how we're selecting, the ISO will govern. If there are amendments posted to the ISO, then the most recent amendment is what governs. Questions can be submitted to the front email address. And I believe there's on the submission site, there's a way to submit questions as well, right? Yeah. So a couple of different ways you all can submit questions to the team. The front program page on the ARPA-H website is going to have FAQs, if it doesn't already, but we'll also be posting answers to questions on sam.gov. We won't be responding to questions via email. Because we want to make sure that this is a level playing field. So questions that come in are going to be answered for everyone. With that, I say, keep in mind when you submit questions, right? Don't submit proprietary information in those questions. We really want to make sure that everyone gets the answers to the questions that are asked, and we don't want to compromise any of your organization's proprietary information in answering those questions. This bullet is here, and I'm going to say it again because it is so important. Please register for SAM early if you have not. And that last bullet is here multiple times. I'm saying it multiple times because it is absolutely the most important item. Read the ISO in its entirety, every single word. Read it twice. You might find something the second time you missed the first time around. Right, so I'm going to talk about the cost and some administrative requirements here. We talked about the solution summary and the rough order of magnitude basis of estimate that we want at that stage. If you are interested in proposing resource or cost share, make sure that you include that in your solution summary submission so we're aware. The volume 2 of your proposal is your cost proposal, and so you will submit both an Excel spreadsheet and it's a cost and pricing support data, so a narrative. We don't need a PDF of your Excel spreadsheet, right? What we need is explanation and documentation that supports the dollars in your spreadsheet. Again, these are taxpayer dollars. We have to be very, very smart with these dollars. And so we do need to look at what are you proposing as the price and why are these prices here? Do they make sense? Do we need to have conversations about them? So make sure that any supporting documentation you can provide or explanation that is provided in that narrative document so that we're able to fully evaluate your costs. The administrative and policy requirements document. So you'll identify your team members. This is where we'll talk about organizational conflicts of interest. So there's language in the ISO that addresses this, but you will actually address this in the admin and policy requirements document. Security disclosures. So we will need, the current and pending other support information and bio sketches for all of your identified senior and key personnel. We use the NSF forms for the bio sketches. Thank you. Here you'll talk about the novelty of proposed work, right? So making sure that we don't have multiple government agencies funding the same work. Intellectual property. So in the ISO, there's language about intellectual property and what we're expecting to receive, but this document is where you will make your IP assertions, right? If you want to assert more restrictive IP rights, this is the document where you do that. Human animal subjects research. This document will also capture that information, and you'll hear a little bit more detail about that in the next presentation. And, a lot of the representations that you will also see in SAM are going to be here, unpaid, delinquent tax, felony convictions, those types of things that we have to look at. Please make sure that you read the instructions in that document very carefully. I will admit it is a bit of a hodgepodge of a lot of different things, but they are all really important. And what we found is that not following those directions can sometimes hold up the negotiation of your award. So the more closely you follow the directions in that document, the quicker we can get you to an award. This is attached to the ISO. This is the ROM template that you'll need to fill out when you submit your solution summary. So you can see here, we're looking for high level numbers. We're not digging into, individual labor categories and labor hours and those types of things. At this stage, we just want your high level numbers so we can get an idea of where your pricing is going to be. Volume 2, the cost proposal. So I talked about the Excel spreadsheet. A template will be provided if it hasn't been already. You must use that template. You must include all of your costs, both direct and indirect costs. If you're going to have consultants, they need to be included in that spreadsheet. Any subcontractors that you're proposing should be included in that spreadsheet. If you're proposing cost sharing, resource sharing, that should be included in the spreadsheet. When you're working in that spreadsheet, please don't change any of the formulas. Please don't delete any cells, columns, rows, or anything like that because everything is linked together. But make sure you fill out the spreadsheet in its entirety. The cost and pricing data support, I mentioned that, but make sure that everything is there, quotes, explanations, anything you need to provide us so that we can evaluate your costs. We are going to be issuing awards with negotiated milestones for payment. So payment will be as you achieve milestones, you will receive whatever payment amount has been negotiated as attached to that milestone. So that's something for you all to think about as you're putting your proposals together, right? What types of milestones might be good for payment? What payment amounts? How frequently might you need to receive payment? Keep those things in mind because if you move forward to negotiations, you'll need to negotiate that as part of your award. All right, so make sure that your cost proposal includes all of the funds that you are requesting from ARPA-H, right? We likely will not be adding things later. So your proposal needs to be complete and include all of your proposed tasks, everything you're going to need, any cost share details. We do want to see the cost broken down by fiscal year and phase. So it's easy to put the award together later. Supporting documentation again, and then an itemization of your team members. So there is a section in that spreadsheet template for you to list out all of the organizations that are part of your team and what the breakdown of their costs are. If you're going to use consultants, I mentioned that they have to be included, but make sure you provide some sort of documentation justifying that whatever rate that consultant is charging you. When you're thinking about things like purchasing equipment, materials, when you're thinking about animal subjects research, and you're building your cost proposal, think about the timing of these things. If you need to make a major equipment purchase and it's going to take a long time for that purchase to come through, for that piece of equipment to get delivered, then you want to think about where in your timeline do you actually need that money for that item of equipment, right? Don't wait until you need the equipment to propose those costs. So as you're breaking down your proposal by fiscal year and phase, think about where are those long lead items, where will you actually need to spend the money in order to be successful in your project. Make sure your costs are consistent with the submitted task description document. That is something that we look at to make sure it all makes sense and it all lines up. If there is some sort of discrepancy and there is a reason for it, please make sure that there's an explanation for that. Make sure your costs are realistic for your proposed approach, right? Don't propose $100,000 for a $15,000 car. That's not very realistic. Don't propose a vehicle if you don't need one, right? So make sure that your costs are realistic and align with your technical approach. And again, I'll say submit the spreadsheet in Excel form with all formulas intact. Please don't convert the spreadsheet to PDF. Right? Don't change the formulas. I mentioned that already. Don't delete rows and columns, and don't cost strategize. Propose what you think is going to be necessary to do the work. Don't try and, come in really low and game the system that way. We need to make sure that your costs are realistic. Otherwise, you won't be successful in your execution. Obviously, don't come in with inflated costs, but make sure that you aren't cutting yourself short in how you propose your costs. Right. That's it for me, but I'll be around for questions during the Q&A session.
Hi, good morning. Michael Simic, HSF. I'm going to talk to you a little bit about exciting animal subjects research. So what is an animal? Well, it's either living or it's dead. It could be a vertebrate, be a fish, amphibian, or an egg-laying vertebrate. And if it's dead, it has to be used for research. We can't just leave dead animals around. And what's not an animal? Well, an unhatched egg or an invertebrate. And for those of you that, might be going to the grocery store thinking I'll just buy my mice there, or a slaughterhouse, please don't do that. ARPA-H does not like that. Some regulations. So these are things that your organizations and institutions should be familiar with if you have done this in the past. But if not, please read these. So the Animal Welfare Act and Animal Welfare Regulations, those are managed by the USDA. And the establishment of the IACUC, the Institutional Animal Care and Use Committee, is something that you'll need to be very familiar with, and your organization needs to be very familiar with, because they're going to approve all your protocols. The other portion is managed by the NIH, and they manage the husbandry requirements, veterinary care, et cetera. And since this is animal, you're going to have a veterinarian on that IACUC board. Award policies. So anyone doing ASR must have these things in place prior to starting work on animal subjects. So you need to have the approved IACUC protocol, valid assurance on file with the OLAW, talk about that, the VAST, the vertebrate animal section complete, and if you're working with multiple organizations or you have multiple sites that you may be performing animal research, you need to have an interinstitutional assurance. All these things need to be approved by ARPA-H prior to start of any animal work. Now, if, for example, you don't have some of these things and you're going to get them in place, you might know that you're not going to need the animals until year 2. We can issue a restricted award and then lift the restriction when those activities are going to begin, as long as you have all those approvals in place. So the assurance, as I mentioned, that's something that's on file with the OLAW. And there's 3 types. There's a domestic one. Note that an assurance is valid for 4 years. I'll talk about the protocol. Those are only valid for 3 years. So there's a little bit of a change there. If you're working with a foreign institution, some overseas organizations that provide animal research, they need to have one that's approved by also by the OLAW. And then back to the interinstitutional. So if you're a prime working with a university, they have all the protocols in place. You can perform the work there as long as you have the interinstitutional assurance. Now, the IACUC, this is very important. This organization or committee approves all the protocols. Everything has to be approved by them. If you're doing animal subject research, if it's international, again, they have to approve it. They can have an equivalent to the IACUC overseas, but it's made up of 5 members and a veterinarian. The veterinarian is key because it is animals and it's appointed by the institution. Many of your institutions, universities have these in place. They do this on a regular basis. So this should be easy. Companies, you might want to think about this early because it takes a while to get set up and through the system and through the processes. The VAST, the vertebrate animal section. So here in your protocols, you're going to provide the description of the procedures. You're going to do the justifications. All these things must be in place prior. As I mentioned, read the ISO was the message before. The message here is all this has to be in place prior to start working on animals. Now, the restricted awards. So a restricted award, as I mentioned, is something that you've gone through the negotiations. You've been given the authority to start spending money, but you're not allowed to work with any animals. Once you get all those protocols approved, once you get everything in place, you can start working, and we'll do a contract modification to the other transaction, lift the restriction, and the work can begin. So think about timing. We talked about, buying long lead items. Same thing with animal subject research. If you're going to do this in month 3, you better have it pretty early. If you're going to do this in month 12, okay, you have a little bit of time. So just think about timing. Same thing like you do with long lead items. The other item is protocol amendments. So things change. You might decide that you're going to need a different animal, or you're going to change a protocol or a procedure. These amendments have to be approved. So again, once you make that decision that you're going to go from a rat to a mouse, you need to know that. If it's just a grammar check issue in your protocol that you wrote up, we don't care. It's fine. It doesn't need to be approved. So your assurance is valid for 4 years, but your protocol is valid for 3 years. So think about the length of your contract. If, for example, your contract is going to go for 48 months, you're going to have to redo your protocols before you start that work in year 4, assuming you're going to use the animals in year 4. And again, they have to be approved. And then the last one is non-compliance. So if you're non-compliant, there's an issue in the lab, something occurs, you may need to be retrained, protocols may need to be updated. Serious issues of non-compliance can cause cancellation of the award. Have not done that yet, but it has happened in the past. So with that, I think we're going to go to the panel, right?
Hi.
That works.
Thank you, everyone. So a quick question around maybe a follow-up question, but quick question about the solution summary. So if we're a group that are focused on, let's say, only TA1, do we just need to submit our solution to the solution summary, or the entire proposal of who else will do TA2?
You'll need to submit the entire solution because teams are required to be able to attack both TAs, right? You have to address TA1 and TA2. So all of your submissions should be one cohesive submission with all of your team members.
So the follow-up question is, only Prime submit a solution?
Yeah, so you'll work with your subs, your team, your partners to develop the solution summary and the proposal, but the Prime will be the one that actually submits, that pushes that button and gets it to ARPA-H.
Thank you very much.
Hi, maybe this is not easy to answer right now, but it's unclear to me what the indirect cost should be. I mean, is it our previous normal indirect costs or now down to 15%?
The 15% restriction that came out from NIH does not apply to ARPA-H. We are still evaluating indirect costs in the way we always have, right? So if you have a negotiated rate agreement, that's what we'll use. If you don't have that negotiated rate agreement, then provide us with however you typically operate. We are not restricting at the 15% or at any number.
I was just curious, how many awards do you anticipate making, if you can say that?
We can't say how many awards. It is multiple, right? You anticipate multiple?
Yeah.
We anticipate multiple.
More than one is the answer.
I had a question about the review process, and what do you anticipate, the review process look like? Would it be a peer review process, common or similar to the one that is typical NIH grants are going through, or what sort of a review process do you anticipate?
We don't follow the peer review process that you're used to with the NIH grants. What we do is we have PM, and we pull in other government evaluators, other government employees who have expertise in these areas. We also have a large group of subject matter expert contractors at ARPA-H who help us out. They will evaluate your proposal against those 5 criteria that are listed. And typically we go through and identify the strengths and weaknesses of your proposal as they relate to those criteria, and then selection decisions are made based on that.
So thank you so much for talking. So is there any lower or up limits for the funding? I'm not asking how many awards you can afford, but is there any limitation for the numbers?
We don't have any hard limitations on the funding, right? We fund based on the what's in the budget, overall, obviously, right? We want to make sure that your pricing is, again, realistic for your technical solution. We might have some proposals that get funded at this level because that's what makes sense, and some that get funded at this level because that's what makes sense, right? But there's no upper or lower limits that we set ahead of time. We're just going to review based on the merit and what makes sense for the program.
Hi. Sorry, this is a weird question, but would you consider the hippocampus and like memory to be part of the neocortex and within the scope of this program?
No, just the neocortex, not like archicortex or hippocampus or something. Thank you, though. Maybe in another program.
Hi, a finance question. So per the ISO and the slides, federally funded research centers and members of the federal government are prohibited from being a prime or a subprime. If you wanted to work with a group that receives quite a bit of federal funding, but is not, a designated federal research center and has employees who are not members of the federal government, I'm seeing a nod. I'm assuming that's a thumbs up.
Yeah, we are not limiting, large businesses, small businesses, businesses that receive a lot of federal funding, businesses that have never received federal funding. It's all open. I do want to make one quick comment. I mentioned the federally funded research and development centers. There's another entity called UARCs. If any of you are familiar, UARCs we do treat as regular performers. So while FFRDCs cannot participate as primes or subs, UARCs can. So want to make sure I make that distinction.
In the solution summary, would you want an LC expert to propose the exact ideas, or would you want that in the full proposal?
The LC component will grow with the program. So early on, you just need to have a plan for how you're going to identify potential issues with them. You don't have to have the specifics yet because some of them, we don't know. So that makes sense.
Got it. Thank you. Yeah.
Should the proposal include safety talks, or this will come after?
Should they include what?
Safety talks, GLP safety talks, or this will come after the pre-IND?
No, the product, the precursor tissue needs to be GMP ready. So it will include, safety talks.
Thanks.
I have a task 2 question. It seems pretty clear about the large animal model and what that goal needs to be. I think the language of the small animal model is not quite as clear. Is that going to be required, or just whether you scientifically justify its inclusion or exclusion?
We're very concerned about the ethical use of animals. And so the more that can be done in rodents, for example, the better. But we are also aware that there are certain things you cannot do or accomplish in rodents that you will need other models. So, we'll let you draw the line on what assays can be done in which model, but ideally that's what you're balancing, minimizing the use of more sentient models and being able to execute and get the answers you need.
Question, is a foreign collaborator from China permitted?
China's a bit of a nuance. So if you have individuals on your team who are Chinese nationals, right, that's not automatically a prohibition. If you are collaborating with an entity that is in some way connected to the Chinese government, that's likely not going to be okay, right? I will say, put together the team that you think you need. We will not be making selection decisions based on country, right? The selection decisions, again, are going to be based on technical merit. So, and if we find later that you've been selected and there is an issue, then that becomes part of the negotiations and how do we handle that issue? And it might mean that you need to swap some people out. It might mean that there are firewalls that you need to put in place, but it won't prevent you from being selected for negotiation. It's just, it potentially could be an added piece of negotiations.
If it were approved, does that mean funding would go to that institution?
Yeah, so if the way the funding is going to be handled, right, all of the funding will go from ARPA-H to the prime, and then the prime distributes funding amongst the subs. So that's the answer is yes, but that's how the funding would be distributed.
quick follow-up question. So can the same group be a sub for several submission while also being a prime for its own submission, right? And can a prime select, let's say, several groups as potentials for, let's say, TA1, two different methods to producing cells in its submission, as plan A and plan B, for example?
So to the first part of your question, yes, right? The ISO does allow for entities to be a part of multiple submissions. So that part is fine. As far as submitting, a plan A and a plan B, that is likely going to need to be two proposals. Is that your preference or?
Not necessarily. So it could be proposed as a mitigation strategy. So it's one TA, so it remains part of the one proposal, but you can have like more than one approach mitigating the risk of one failing, for example. It would be perfectly acceptable.
Yeah, was there a predetermined down select in this ISO? I didn't notice one where after a certain milestone.
So ultimately, later in the program, there will be some down selects, but it's not mentioned specifically in the ISO, I don't think.
As with everything, it's availability of funds is who is selected, and everything is dependent on availability of funds.
To that point, if you receive an award, you will not at the time of award receive the full 5 years of funding, right? That's something that is new for some people. So I just want to make that clear. You will receive funding to get you through, a certain period of time. It could be a year, it could be 2 years, and then that future funding again is based on the availability of those funds.
The initial proposal, when you get what kind of feedback you get? Is it binary, like encouraged or non-encouraged, or do you get some feedback, some recommendations, like, for example, we like this, but this subpoint has to be modified, and has so what kind of feedback you get after the first round, or is it just binary?
So you will definitely receive an encourage, discourage. We do try to provide some of that more detailed feedback. However, that's going to be based on how many, if we receive 200 solution summaries, the amount of feedback you get will probably be a little bit less than if we receive 20, right? So, but we do try to provide more than just an encourage, discourage when we can.
What you would plan on doing as part of that feedback calls or not?
Yeah, I don't have too much to add other than, for encourage, there might be more detail. I don't know if that's what you're thinking, or
yeah, and then a call or not.
Do feedback calls for solution.
Yeah. We can do that too. Yep.
So in the meanwhile here, so should we aim for a U.S. market or international market with the product specifically?
You want to really focus on the U.S. market, right? Because ARPA-H's mission, right? We're trying to create better health outcomes for all Americans. We're using American taxpayer dollars. So while a lot of our research is going to benefit the world as a whole, we are really focused on Americans benefiting from our programs.
Two questions, both around kind of technical project management. So obviously, everything doesn't always go to plan. Let's say, snap our fingers. Someone's been selected for an award. We're 2 months into TA1, and we all realize, oh goodness, the plan's just not going to work. But we think here's another option that is a radically different budget, radically different team members, etc. What happens in that scenario?
So, we've talked about how other transactions are different from a lot of the more, well-known government contracting vehicles. One of the things about other transactions is that it does allow us to pivot. So this is cutting edge research and development. Some things just aren't going to work. So we do have the ability to pivot. Now, how much we can pivot is going to depend on a lot of things, right? Because one of the things you said in your scenario was wildly different budget. Whether or not we can accommodate that, we don't know. But we do have the ability within our other transaction awards to make changes, negotiate those changes, and have those discussions.
And again, back to the availability of funds there. And then also within that change, everything would likely require a modification to the statement of work, the scope of work, and that would have to take some negotiations. It's not just you adjust on the fly. The agreements officer would have to sign off on all of those things.
Hello. Hi. Very quick question. So, John, in your presentation, you alluded to just regular meetings with the different groups, that the awardees in this case. The question I had is, could you elaborate on that a little bit more, I guess? What are you thinking in terms of regularity with meeting with subs versus primes? Is it phase specific depending on how the project's evolving?
Yeah, definitely the primes, but we would encourage any significant sub to be part of the discussion as well. These are meant to be helpful for both sides as much as possible. Input from me that could be helpful to keep you aligned with the program, so we're all going in the same direction. But also for me to learn about your progress and make sure it's happening. And
Thank you.
I understand that there is no transplantation of human cells or human tissue to animals. That was my understanding. Yes?
No, you can definitely do that. You can't have chimeric animals, derived from chimeric embryos.
Okay. So you can make a transplantation. Okay, thank you.
How many teams do you expect to fund? And if multiple teams are funded, do you expect or would you anticipate any kind of team switching halfway through a project?
More than one. We don't know yet. It's going to be based on the quality of the proposals that come in. As far as team switching, pivots can happen, right? If necessary. But again, that would be lots of discussions. It would have to be negotiations, modifications to the award itself. So ideally, the team you go in with is going to be your team, but it's not out of the question that things can change.
This is just a question on the commercialization aspect in like the GLP and FDA. Are those aspects, should those be like talked about in detail in the proposal, or is it more of like at the completion of the proposal, there will be kind of a pathway to FDA GLP tests?
Towards the goal of the proposal is to have a GMP product, but that's expensive, and so like you'd want to follow GLP probably earlier on, and then at some point make the transition to developing the GLP product. I want to say more than that, but yeah, it's
And the level of detail is up to you as to how much you want to provide. Just know that the reviewers come from different backgrounds. They have subject matter expertise in the overall, but may not have detailed level of expertise on FDA regulatory guidelines, et cetera, et cetera. So you have to weigh throughout the proposal, weigh in your minds the value of the detail you provide versus the space limitations of the proposal.
Technical question about the approach for designing the engraftment. So one of the deliverables, obviously in the middle of technical area 1, is to have the cell banks, cell types, and then some type of ECM and structure for making the engraftment. In the ISO, it talks about biogels at some point for storage. ECM is put out but not necessarily defined. Is there a particular approach that you all are looking at in terms of gels or hydrogels, spun scaffolds, wet scaffolds? I'm just curious what's on the table.
We're open to a lot of approaches, especially innovative approaches. I think for us, we want to see something that's going to be as close to natural as possible. And so how you measure that, like whatever your approach is, we want to see that you have a good way of comparing it to what natural tissue is like. So because that will, in our mind, increase the probability of success. I don't know if you want to say more, John.
Maybe a good rule of thumb is whatever your approach is, justify it scientifically, technically, in the proposal.
Related question, what is the volume, the size of because for a mouse, for example, you might need much less than for a human. So what size of graft are you looking at?
Yeah, I didn't really talk about it here, but it is mentioned in the ISO to consider the growth of the precursor tissue, right? Well, depending on the maturity stage of the tissue you're putting in, there will be more or less growth, but you should consider what the normal growth of that precursor at that stage would be to accommodate that in a lesion site, for example. It comes down to math, really, just calculate the volume of growth that normally occurs. Yeah.
And just to clarify, just imagine you have very specific aspects of the entire procedure, like, for example, how to prepare the grafting to make the chance of graft survival much more viable, or to strengthen the survival of the individual cells. Have a very specific procedure in mind that was not applied yet, but you don't have the entire, like, from the graft production. So what is your recommendation if you like to submit only very specific aspects of the entire translational process, basically? But you mandatory have to team up with another team who takes care of the other parts, or can you just somehow really focus on this very specific aspect you can contribute to?
Each proposal has to address all the milestones of both TAs with the specified metrics.
Okay. So then basically also the purpose, one of today's, if you have specific things which you cannot provide, then team up today, because it's a very, very close timeline to really basically to have a holistic solution, basically.
Yeah. So interact with people, meet people with complementary approaches. There's also a teaming page where you can put your expertise as well as who you would like to, what you would like to team with, what expertise you'd like to team with. So, yeah.
So very much scientific questions. I noticed that there's a description about the size of early, stage of the neocortical tissue. The number is 1 millimeter in diameter and 200 micrometer in thickness. So is there any sort of number drawn from a scientific experiments or literatures which can sort of as a reference? So because when we would like to have certain level of a guideline for us to how we can match this, the number, exact number guidance here.
Yeah. Just, go with what the size of normal tissue at that stage is, like it's published. People have looked throughout development at human development at all these tissues and with scale bars and everything. So you can get the sizes depending on the stage. The example given is not, a strict size, so it depends on the stage of the precursor tissue that you're.
I have a question. So I think the goal of this program is to develop precursor tissue that can grow and mature within the host tissue, right? So how about the different approach, for example, develop the mature tissue and the transplant? That is appropriate for this program, or is that kind of application is also allowed?
If you can argue that might work, then you'd have to argue effectively that might work, right? But the issue with mature tissue is those neurons do not project to other parts of the brain. So maybe if you have a solution to that's reasonable, then it might be worth considering. But yeah.
Yeah, if you remember Jean's diagram of embryonic development of the cortex, and that there was iteration back and forth, it may be that your approach is at an earlier stage or at a later stage in that development of that chart, but you have to iterate and provide justification and rationale for why you're going at those various timelines and stages of the development of the cortex. Is that a different way to say it, John?
Yeah.
Okay.
We have a couple online questions we're going to review. Will the front program accept non-neuronal, non-glial transplant cell types? What if we propose a cell transplant therapy that includes neuronal or glial proliferation or survival that promotes regeneration?
So I think John mentioned in his talk that we're not looking for bystander effects. We're looking for a tissue that resembles natural as possible. So cell types in what you're producing should reflect like the natural counterpart. So yeah, like neurons aren't the only thing in there. There's a lot of different types of cells in there. But if you're leaving out a cell type, then you're not going to get a fully functional tissue. So you want to make sure you have all of the appropriate cell types.
I might say it in a simpler way as well. So cell-based therapies will not be considered. We're looking for tissue level, repair.
Great, thank you. Another one we have online is, will these slides be available on the cost sheet? These slides will be made available later this week.
Do you have mechanisms to accept proposals that are not complete or keep track of solutions that are, let's say there's a compelling T1 solution or a T2 solution, but maybe, teaming is not feasible in the time frame? And is there a way to sort of keep track of those groups in case of, down the line when there's proposals that are funded as backup mitigation strategies, et cetera?
We're really looking for complete proposals. That doesn't mean that a team that gets selected and awarded might not be out there looking for a partner at some point down the road, if they need to change their strategy. But we don't typically reach out and say, hey, can we talk to you about coming and joining this program? If you're not able to submit a complete proposal by the deadline, we do have kind of these open ISOs, one for each mission office. Now, we won't make awards that are duplicative, right? But if you have, an idea that you think ARPA-H might be interested in, you can submit it anytime that way. But again, we won't fund duplicative proposals, but just an option if you have other things that you'd like to submit.
And maybe I'll just say that like our goal is for the program to succeed, and so. There will be people who are selected, and if you can engage with those people and maybe you can help them be successful, so that would be my recommendation.
Shows on a diagram pretty much that the first year would be the development of the tissue, and then the second year of the animal work could start, etc. But in some cases, it could be that there is some additional work needed on the animal to make a preparation. So it's like there is a flexibility that, for example, the animal work would start kind of a preparatory work from kind of a day one, to have after 1 year to have everything ready.
Yeah, I think you're encouraged to start as early as feasible for you on any of these milestones. Right? Mm-hmm. That's just to your advantage. The ends are more what we're concerned about. Yeah.
Thank you.
Got a couple more online questions here. First one, are non-human primates allowed?
Yes.
Perfect. Thank you. One more here. Would a small molecule or glycolipid that promotes neurite extension and integration be relevant for this program? Potential benefit would be for tissue culture generation in TA1 and for successful integration into host during TA2A.
Sorry, any additional methods on top of generating the tissue and engraftment of that, anything that improves the likelihood of success of the engraftment? We're interested in proposals of approaches for that. Anything you can think of.
But again, as with everything, you would need to justify why you think it adds value or is needed. And you'd have to provide a plan for showing that.
Great, thank you. One more here. Is there only one cycle of submission?
Yes. Follow-up question about the parallelization of work. So if, say, for planning for an IND, obviously you'd want to either have someone in-house or bring someone on who can help with that, like a regulatory consultant. It might be beneficial to bring them on earlier in the project, but if you've not identified who that specific person or group would be by the time of submission, could you put in a line item that says, we have allocated X, Y, or Z for regulatory consulting or to bring on this capability, but we haven't identified who or what it will be?
Yeah, that's fine. Just make sure that they, you do talk about what that person's going to do and how they contribute, and that you do have a line item in your budget for them, because you won't be able to add that later.
At the intro, we discussed this office is primarily interested in the sci-fi type ideas for therapeutics. But one thing I was curious about is for the evaluation of submissions, are you taking into consideration scalability and cost to patients as part of the solution submitted?
Yeah, so, those are things that need to be thought about, again, as the program progresses and it becomes clear what the product is. Having a plan for commercialization is built into the program. The actual commercialization doesn't come until after clinical trials, right? So it's a plan, but it has to make sense. And so, yeah.
Two questions. Just to clarify, even you have multiple teams, but it's basically one PI who submits, or you have multiple. So there's one lead who submits the entire package, basically. Even and internally they're teamed up, basically. Just confirm.
There's one prime that submits for each proposal.
Then second, if you have some proprietary solutions that are not yet IP filed, basically, remind me, please, will this be public information, or do you still have some, so the proposal itself will be, so you could still file at a later point, or please remind me how that works.
Yeah, so your proposals are protected. We consider them, competition sensitive. Essentially, everyone who's reviewing, anyone who touches your proposal has signed non-disclosure agreements. We protect the proposal information very, very closely. In general, it is not our intent to own IP, right? There are rights that we want to the intellectual property, but we fully expect that performer teams will be submitting, your own patents and owning those things, particularly if it's background IP, right? Something you're bringing to the table. We're not going to reach our hands into that, but the information you submit is protected. We don't make it public.
I don't know if this has been asked before, but do you have any suggestions or advice about PR around this project? Should we or should we not talk about it? And how should we talk about it?
Once the proposals come in, you'll see we'll go quiet a bit, right, while we're reviewing them. Once awards are made, so we do not publicly announce who has received an award or who's been selected for negotiation for award. And we ask that if you are selected, that you kind of keep that within your team. But once awards are made, we make public announcements. And if you as an awardee want to also make an announcement or have some PR, we'll put you in touch with the ARPA-H Compass team. Compass handles our, public release of information, and they can work with you on making sure that, everything that you're putting out aligns with what ARPA-H is saying.
One more online question here. I believe it was stated this is expected to be a single implantation step. Can there be an initial step which modulates the injury environment followed by an implantation, or does this need to all be in a single implant?
As long as everything's IACUC approved, it doesn't have to be a single, surgical procedure. There could be steps to it. You can imagine that depending on the approach and the monitoring methods, that there might be more than one surgery, but yeah, so justified. Yeah.
Great, thank you. It's a LC question. The solicitation states that the program management team intends to make LC-related expertise available to performer teams. Who are the LC staff at ARPA-H, and how will this expertise be made available?
Thanks. My name is Megan Palmer. I'm the lead for responsible innovation at ARPA-H. And so we've been working with all of our programs, including Jean's team. Really, Jean and the team lead the approach, but across the agency, we have a variety of different efforts that we integrate within our programs that are appropriate to their goals. And so here, there is the expectation, of course, that your teams will choose the experts that are most relevant also to your goals, but then we'll also take the opportunity to supplement that with additional expertise that we will couple to these programs. And so we see that as being appropriate both for making sure that the folks that you work with on your team are folks that you maybe know, trust, have worked with on other programs, but also we can make sure that we're addressing emerging issues and gaps along the way.
Awesome. Thank you so much. One more here. Do solution summaries need to address all milestones, or can a solution to one or more milestones be submitted in the solution summary phase and team joining formation executed before full proposal?
All.
Thank you very much.
All right. Thanks, guys. Great questions.
Thank you.